Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about Mars, and specifically we are going to focus on the geology of Mars and its atmosphere. So what do we know about Mars and how have we explored Mars in the past? Well, Mars is one of the best explored objects in the solar system. And we had flyby of Mariner 4 in 1965, which is the first successful Mars flyby. And 6 years later, we had the first spacecraft to orbit another planet in 1971. And that was the Mariner 9 spacecraft orbiting Mars. So better to orbit Mars if you can, because you can continue to study it instead of just getting that glimpse of it as you fly by. Now in 1976, we had the first successful landing on Mars, and that was the Viking spacecraft. And there were two, Viking 1 and Viking 2, that would search for the potential of life on Mars. And we had in 2012 and then again in 2021, we put rovers on Mars. Now there were some previous rovers as well, but the Curiosity rover in 2012 and the Perseverance rover in 2021 are currently, as of this recording, still exploring the surface of Mars. And we also in 2021, as part of the Perseverance program, sent the first helicopter to another world, and that is the Ingenuity helicopter. So a helicopter that was able to fly in the atmosphere of Mars. Now, why was that important? Well, it's a chance to be able to explore a little more than what you would be able to do with just a rover. The rovers, of course, have to look out for obstacles on the ground and move slowly to be careful as to not get stuck. Whereas the helicopter can then fly over obstacles. So this was kind of a test to see how well a helicopter like this might work to be able to explore Mars in the future. So how about samples of Mars? What do we know of Mars? Well, the landers and rovers were able to study samples on Mars. At this point, no samples have been returned to Earth. So we have studied them with the equipment that we could take to Mars. However, the Perseverance rover is actually collecting and storing samples for a potential return mission in the future. However, we do have some samples of Mars already here on Earth. How do we get that? Well, meteorite impacts. A massive meteorite impact on Mars could throw material up into space. And if it is a large enough impact, would reach escape velocity from Mars and could go into solar orbit. Some of those pieces could then eventually strike Earth. So we have samples of several planets and our moon that have been obtained this way. And by studying the composition and the specifics of the rocks, we can match them up and figure out where they may have come from. These are relatively young, only 1.3 billion years old. So not going back to as old as many of the asteroids, going back 4 billion years or more, but relatively young and likely the result of a very large impact on Mars in the past. Now, when we look at Mars, we do see various surface features. In terms of craters, we see more than we see on Earth or Venus, but fewer than we see on Mercury and the moon. So that puts it in a intermediate age between them. Some of it is a little older, and some of it parts of Mars are younger surfaces. When we do look at volcanoes, we have massive volcanoes compared to Earth, and we will look at those. You can see a couple of them in the image here off to the edge. There's three, and the largest, Olympus Mons, we'll look at shortly, is right around the edge of Mars there. There are great canyons, which in this case are tectonic features that would stretch across the United States. So we see things like this great tectonic feature, Valles Marineris, that would be as large as the distance across the entire United States. And we will also see flowing water features. So we're going to look at all of those in a little more detail. Let's start with the volcanoes. Well, the largest volcano is Olympus Mons, pictured here. and that is the largest volcano in the entire solar system. How big is it? Well, it is 3 times the height of Mount Everest. So while it's a lot more shallow, it still is much, much taller. So if you've climbed Mount Everest, you've gotten a third of the way to the top of Olympus Mons on Mars. How big is it? Well, it is comparable to the size of Pennsylvania, New York, and New Jersey combined. So you can see here with those 3 states in the eastern US overlaying it, and we can really get an idea of how big this volcano is. The massive caldera at the center is the size of one of the smaller New England states. We also have the Tharsis region, which is a hotspot on Mars, similar to Hawaii on Earth, where the entire region has been pushed up by a large amount, by 7 kilometers, because of pressures from below and lava flows. So from volcanic activity. Now this whole region is raised up, and we can see and put it in a little bit into perspective here as to how big this whole region is. Well, there's Olympus Mons over in on the US in Washington and Oregon. And for distance wise, those other 3 large volcanoes are present in the middle to southwestern part of the United States. And then we have the uh, Valles Marineris kind of starting off here to the edge and cutting across portions of this. It would again continue much further on than this. So this one region on Mars is the size of the United States, but it kind of puts into perspective how massive these volcanoes are compared to our little tiny volcanoes here on Earth. Now let's look at that Valles Marineris. How big is that? Well, it is a 4,000 kilometer canyon. So pretty large, much larger than the Grand Canyon on Earth, 5 times longer and 4 times deeper. However, it is formed by a different process. And what we mean there is that the Grand Canyon is formed by flowing water. And while we will see flowing water features on Mars, this is not one of them. This is a tectonic feature, which appears to be similar to a rift valley that here on Earth. But Mars cooled off too fast for plates to begin to form. So maybe this was the beginnings of plate tectonics on Mars that was never able to finish because Mars was too small and cooled off far too fast. We also see that Tharsis volcanic region to the left is that part of the reason for this rift. So the Tharsis region in the volcanoes would be up over just off to the left here in this image. Now, Mars does have an atmosphere. So let's take a look at the atmosphere of Mars. It is very thin, less than 1% of Earth's as compared to the 90 times Earth's the atmosphere that we looked at on Venus. The composition is comparable to Venus, being 95% carbon dioxide, 3% nitrogen, and 2% argon. So while it's comparable and has a lot of carbon dioxide, there will be no significant greenhouse effect because the atmosphere is so much thinner. In addition, it does not have those thick cloud layers that Venus had in its atmosphere. However, we do get high winds and dust storms, very high winds that will pick up dust from the surface and give planet-wide dust storms that occur. And we can see an example of that. Here is Mars on the left as we would normally see it. And on the right, we see it as it would be during one of these dust storms. And while you can see some of the features, they are very muted. You can see far less detail because of all of the dust picked up from the Earth surface and thrown into the atmosphere. And this is actually how the Opportunity rover mission ended. After a dust storm in 2018, the Opportunity rover was put into hibernation and was unable to be reawoken after the dust storm. Since it depended on solar energy, and with that much dust, it would not have been able to get enough energy. And unfortunately, either the something happened with it, or there are too much dust on the solar panels for it to be able to recharge. And that actually ended one of the missions of the Opportunity rover. Now, Mars does have a couple of moons. So we have Phobos shown here, sometimes called the doomed moon, because it is in a very low orbit, only 6,000 kilometers from the surface, orbiting faster than Mars rotates, and being torn apart by tidal forces from Mars. So Mars pulls on one side more than it does on the other, just as our moon does with Earth, creating our tides. But this is close enough that it can actually start to shred the rock apart. And it's in a decaying orbit, so eventually it will get even closer. Those tidal forces will get stronger and stronger, and we expect that it will be gone in tens of millions of years. Deimos is a little smaller than Phobos, and is the smaller of the two, and is a much more stable orbit, but not really anything large compared to when we looked at our own moon. It's thought that these may be asteroids that were captured by Mars. So since Mars is near the asteroid belt, perhaps these are asteroids that were captured and happened to come too close to Mars. So let's go ahead and finish up with our summary. So we've looked at Mars and some of the spacecraft that have orbited it. We looked at the large volcanoes, including Olympus Mons, and canyons such as Valles Marineris present on its surface. We briefly looked at the atmosphere of Mars, very thin and mostly carbon dioxide. And we talked about the two small moons, which are perhaps captured asteroids. So that concludes this lecture on Mars, geology and atmosphere. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.